This person's texting me because you forgot about them. I remembered I'm all on my own today. Oh, what a mess. Anyways, we're ready here. So, okay, so we had negative 6y and positive 6y gave us 0. 4z and 15z give us 19z. And 12 and 45 give us 57. Amy, what other two equations did you add together to eliminate the y's? B and C. Okay, so did you do probably negative 2 times B plus C? Okay, so that's negative 2x minus 2y plus 8z equals negative 24. And then C didn't change, so I'll just recopy that down. (2x) and positive 2x gives us 0. Negative 2y and positive 2y gives us 0. 8z plus 5z gives us 13z. And then negative 24 and negative 15 gives us negative 39. And something unusual here has happened, where two variables eliminated, but that's okay. That actually makes this problem easier and saves us some steps. So it's okay that that has happened. So I can solve z directly right now. So if I divide both sides by 13, I get z is negative 3. I can then substitute that back into this other equation. Um, 19 times negative 3 is negative 57. And if I add 57 to both sides, I get 7x is equal to 0. If I divide both sides by 7, I get 0. And now to solve for y, I'm going to go ahead and take both of those two answers and plug them back into either A, B, or C. I'm going to choose to plug them into B. For no real reason other than the coefficients are kind of the smallest in that equation. So in place of x, I'll put a 0. And y is what we're solving for. In place of z, I'll put my negative 3. So I have y plus 12 is equal to 12. When I subtract 12 from both sides, I get 0 again. And so there's my solution. Should be 0, 0, negative 3. Again, we write that solution in alphabetical order, so x, y, then z. Does that feel okay, Amy? Mm-hmm. Were you thrown off what to do when two variables eliminated? Yeah. That's a good thing. That saves us a little bit of work. Maya, I saw your hand come up. Sure. What did you get for number 3, just as an aside? Okay. Hold on, give me 1 second. Let me look up my answers. That might have been right. I don't know. Well, let's check real quick. I'm in the wrong folder. Yoo-hoo, computer. Stop being so slow. Okay, number 3 we're asking about? Okay, so you should have gotten no solution here for number 3. Oh, So if you knew that was supposed to be the answer, you knew where you would have stopped and you would have been done at? Okay, and then there was no variable left? So you had like 0 equals 5 or something? Good. That's exactly the indicator that it should be no solution. Yep. So in fact, I think there are 2 on this sheet that come up no solution. So that satisfied you then, Maya? Okay. We can still do the problem if you want, but if you're happy, I'm happy. Okay. Taylor?
Yeah.
Sure. 5 is the other no solution one.
Oh, okay.
Is that?
No, I just got so fractions.
Oh, you got gross fractions?
Yeah.
Well, should we do 5? We can do it. I'm just letting you guys know. I didn't know, like, again, the goal here is that you guys feel good about this. And sometimes just telling the person what the answer is, and they're like, oh, good, yeah, I had something weird like that happening. That's like Maya, who I had a feeling it might have been the issue, was just that's not what I was expecting to get, and I got it. And I didn't know what that meant anymore, which is cool. Okay. Taylor, what variable did you choose to try to eliminate first?
Oh, sorry, what?
Which variable did you choose to try to eliminate first on number 5, x, y, or z?
Oh, I did substitution. I think that's what I thought.
Okay. Yeah, that's going to get messy.
Yeah.
Which equation did you try to do the substitution with?
I did this one, second one. Oh, second one.
Okay. Did you try to get the x by itself?
Yeah.
Okay. Well, that wouldn't have been too bad for the first go around, right? X is equal to 2y plus 3z plus 25. And then we plug that into A. We have 3 times, but instead of x, we have minus 2y plus 3z plus 25. Minus 3y plus 4z equals negative 23. And I simplify this down. I'm going to just try to do this kind of all in one step so I don't have to write as much stuff. Is that okay, Taylor?
Yeah.
Okay, so I get negative 6 and negative 3 is negative 9y. I have positive 9 and positive 4 is 13z. I have positive 75 that I subtract to the other side to give me negative 98. Okay there? Okay. And then we'll substitute that into equation C also. So I have 4, but in place of x, I'm going to have negative 2y plus 3z plus 25. So 6, oh, good, thank you. I probably said 9 and wrote 6 when I was saying what I was doing. Thank you. That makes a big difference, right? Minus y plus z is equal to 25. So let's see, that's negative 8y and 1 more is negative 9y. Then I have 12z and 1 more should be 13z. Then I have 100, and when I subtract that over, that'll give me negative 75. Taylor, are we okay to hear?
Yeah.
So this is my equation D and E. And already at this point, you might be able to look at this and realize that it's going to give us no solution. Because we know you might notice that the left-hand sides are identical, but the right-hand sides are different. Do you see that? And you could stop right there with that observation to say it's no solution. You wouldn't have to go any further. Feel okay? And the reason I wanted to stop here and make that observation is because you're right, it does turn into like a gross set of fractions from here on out. Now everything would cancel out when you make the substitution, and you'd be left with some gross fraction is equal to 75 or negative 75 or like positive 98, depending on which one you put in where. But all the variables would cancel out. It would just be kind of gross and like inconvenient to get there because you have a lot of fractions going. Amy? Okay. Ava, did you have a question about this one before we get going?
I just have a quick question.
Sure.
So if the answer is infinite IMF, or if there's all solutions, how do you write it as a parametric solution?
That's what we're going to do an example of today. And the homework today, we're going to practice doing that.
Okay,
So we have yet to deal with that in a 3-variable situation.
Okay.
So that's the agenda after we're done with regular questions.
Okay, thank you.
Yeah, no problem. So I'll be right with you on that. And Amy, you said you got stuck on 4. Am I correct on that? Okay. Let me do this. And I'm just going to go put it in over here. All right, that should be, oh, not there. All right. I just needed some space, so I had to move some stuff around. All right, Amy, what did we do first? Which variable did we try to eliminate?
I did A and C.
But what variable?
Variable X.
Okay. So you probably did negative 2a plus c. Okay. So negative 2 times negative 3 is positive 6. Negative 2 times negative 1 is positive 2. Negative 2 times negative 3 is positive 6. And negative 2 times negative 8 is positive 16. And then c is exactly the same, so I can just copy that down. We add down, we get negative 2y, 7z, and negative 4. And then what other pair did you do? Okay, A and B. So we probably did what, like negative 5a plus 3b? Is that what you did? Okay. So that's going to give me 15x plus 5y plus 15z equal to 40. Then 3b is negative 18x. What did I do? What are A and B? Oh, I'm looking at the wrong one. Ha! 3 times 5 is negative 15. 3 times 3 is positive 9. 3 times 6 is positive 18. And 3 times negative 4 is negative 12. So the x's cancel out. I'm left with 13y plus, what is that, 40 or 33z equals 36. Does that look right? I think so. Okay, those will be my new system. So which variable did you try to eliminate here, Amy? Okay. So we probably did 13 times the first one and 2 times the second one. Okay. So that gives me negative 26y plus 91z equals negative 52 and 26y plus 66z is equal to 72. Okay. We drop a negative sign somewhere here. No, doesn't look like it. Made a mistake. What is the mistake? Must have dropped a negative sign somewhere. Ah! Yeah, talk about a goof up. Where were you a minute ago, Edmund? That's okay. So that saves us a little bit of hassle. That can just be 7 now. And then all that stuff is just I'm gonna just change it all. Thank you. Sorry about that, Amy. You know, sometimes we just make a mistake, right? Happened to me. Oh my gosh. And 40 minus 12 is definitely not 36. All right, now I think I got it. You know, sometimes the arithmetic just gets you, right? 5 plus 9 is 14, huh? Ugh. We'll blame that on having a splitting headache right now. Or just having like one of those moments, you know? I am getting older. So what do we got here? 82z is equal to 0. So z is 0. And then we'll substitute that back into one of the previous ones. I'm going to plug it in here because the numbers are a little bit smaller. So there I get y equals 2. So far, so good. Negative 4 divided by negative 2. Negative divided by negative is positive. Yep. And then we got to get our x. Let's plug these back into, say, equation, I don't think it matters, a maybe? Negative 3x minus 2 minus 3 times 0 equals negative 8. Negative 3x minus 2 equals negative 8. Add 2 to both sides to get negative 3 equals negative 6. And divide by negative 3 to get 2. So my answer would be 220. Arithmetic?
Yeah.
It gets you. Okay. Are we ready to move on and talk about the stuff for today, Edmund?
I just have one more question. For,
Sure.
Homework 2, how do you just find the coordinates outside of just like putting it into whatever?
So on 2, here, this one. Oh, I would put them, well, here's the thing. You can't tell whether you should be shading above or below until it's in slope-intercept form.
Okay.
So you have to do that regardless.
Okay.
So you could find the coordinates Without doing that, you can just kind of do it by inspection by picking an x and then solving for the y, or picking a y and then solving for the x. But you can't tell which way to shade, whether it's above or below, until you're in slope-intercept form. So that, while you can do that, I don't, on 2, you really need to do that to figure out the shading. Yeah, because you need the shading. It has to be the y by itself to tell whether you should be shading above or below. Elimination. Well, you don't need to find their intersection.
Oh.
For homework 2, you just need to draw the 2 graphs, do the shading, and figure out where the shading overlaps. So there is no numeric answer. It's just the picture with the shading.
Okay. So we do that.
Yes, you have to have the graph because that is the answer.
Using the form.
Well, no, you can find the coordinates any way you want, but in order to figure out which direction to shade, which side of the line to shade, that's where you need the y equals mx plus b form. Does that? Okay. All right. An example problem here all set for us. So I wanted to talk here today about solving these 3 variable systems that can have infinitely many solutions, and how do we get kind of the parametric form for the solution. Remember when we did this for the 2 variable, we wrote that parametric form for the solution that we could use to generate any point that is in the solution set. This is a little bit trickier when we have a 3rd variable, so I wanted to make sure we do an example. Then I have a homework assignment for you guys to practice this on that we'll just spend the rest of the day working on. Everybody okay with that plan? Okay. So I would approach this just like I would kind of any other problem. So I'm going to use elimination to solve this. And it doesn't really matter which variable I eliminate. They're probably all about the same amount of difficulty. I'm going to use the z's, though, because I like that I have 2 positive z's and then a negative 1 z. That, to me, looks like the nicest situation, although there's no real problem if you did something else. So I can do a plus b. And then I'm going to do 5b plus c for my eliminations. Is everybody okay there? Okay, so a plus b, I didn't change anything. I'm not going to recopy those. I'm just going to add them up from the problem and write down the result there, just to save myself some steps. So that's 4x minus y equals 11. Now 5b plus c, I did change something, so I'll recopy that here. Because it's pretty easy to make a mistake. That's kind of a lot of stuff to hold on to inside your head. And if I take those together, I have the system 4x minus y equals 11 and 16x minus 4y equals 44. Let's make that a little bit more obvious. That's a 4. Looked a little 9-ish before. Is everybody okay with how I've gotten to here? I'm going to take a pause because I see lots of people with their heads down writing, so I'll let everybody kind of catch up because the tricky parts come next. So far, this has been just like everything we've done before. When I look at that system with D and E in it, do you notice anything? Tommy?
You multiply D by 4 to know equal everything to D.
Good. Does everybody notice that? So if you notice that, you can stop right there and say there's infinitely many solutions, and we don't need to actually get the 0 equals 0. I'm fine with you stopping there when you notice that. Was there any indication when we looked at the original system that that was going to be the case? I would say no, right? So what's going on here is there's a couple of possibilities as to why there's no solutions, or infinitely many solutions. When you get infinitely many solutions, what's happening is you can get like two planes that intersect exactly. So when you have an equation in three variables, that's representing a plane. It's a two-dimensional figure like a sheet of paper. If you have two planes that are like just scalars of each other, that's like one plane is 2 times the other, they're the same plane. So when they intersect a third one, that intersection is a line that has infinitely many points on it, right? So that's one way, but that's going to be obvious right from the get-go, because you'll have one equation that's just a multiple of the other. We don't have that there. The other situation that you could have is that you have all three of them intersecting at that one line, but none of them are identical. So you have something kind of like this. It's hard with floppy sheets of paper. Does that make sense? That's what's going on here. So that you would not be able to identify at looking at the three variable system that that's going to be what's going on. There's no way to see that until you do that first set of eliminations. Is everybody okay with that idea? And there's nothing wrong if you didn't notice that this was infinitely many solutions right here and you did that final elimination, got 0 equals 0. That's fine too. No reason that you can't do that. I'm just trying to save myself a little bit of work. You know what I mean? Okay, so now how do I come up with the parametric solution? What I'm going to do is I'm going to pick one of these two equations, D or E. It doesn't matter which one. I would pick D because the coefficients are smaller. And if I can save myself a little bit of hassle, that's, if the numbers are smaller, there's a little less work to do. That's what I would choose. From that D, I'm going to isolate one of the two variables. It does not matter which one you isolate, but just like for substitution, we can make our lives easier if we choose wisely here. Which variable would be the easier one to isolate? Y or X? Y. Good. Why did you pick that one? Because the coefficient in front of the y is a -1. When we divide by a -1, no fractions are created, right? If we can avoid having to deal with fractions, let's do that. It makes life quite a bit easier. Although, for the record, it is okay if you did something and generated fractions. It'll be fine. In fact, we'll do this same problem assuming that we got x by itself instead of y, just so you guys can see the difference. So I'm going to subtract 4x from both sides and then divide by a -1. Everybody okay with what I did there? So I'm going to start filling in my parametric solution now. So for the y's, I'm going to write 4x minus 1. That goes in the y spot because that's what y is equal to. Is everybody okay with that idea? Since y is written in terms of x, x is like my parameter, so x is just x. Everybody okay with that? Now what I'm going to do is I'm going to take that equation for y, and I'm going to plug it back into either A, B, or C, and rewrite that in terms of x. So I would choose equation A, because if I look at the coefficients involved, there's a coefficient of 1 on the z. It makes life as easy as I can get. So I'm going to plug that into there. So I have x plus 4x minus 11 plus z is equal to 7. So if I combine my like terms, 5x minus 11 plus z is equal to 7. If I subtract 5x and add 11 to both sides, I have z is equal to negative 5x plus 18. So that's what's going to go in the z coordinate spot. And that's one possible solution. One is enough. I would never ask you for more than one of the possible ways to write that parametric solution because they're all equivalent. It doesn't really matter whether you parameterize the x, the y, or the z. It doesn't really make a difference. Let's kind of show you what this would look like if instead of getting the y by itself, we got the x by itself. Just to show you the same process, because again, this answer that we're going to generate is an equivalent answer. We're just doing it a different way so you guys can see what would happen. Amy? Because the other equations are written in terms of x. So x is like my independent variable. That's my parameter. That's the thing I get to choose, and then I find the other coordinates based on that choice. Does that make sense? Exactly. So if in this case instead we had gotten the x by itself, I would add y to both sides and then divide by 4. So here I would write down for my parametric solution. For the x, I would put 1/4 y plus 11/4. And then because that equation is written in terms of y would be the parameter in this case. And then to find my answer for z, I'd plug this back into either A, B, or C and get z by itself. Does that make sense, Amy? Yeah. So let's go ahead and do that final step just so we know what the answer looks like. So again, I'm going to plug that into A. So in place of x, I'm going to have 1/4 y plus 11/4. Then I have plus y plus z is equal to 7. So if I combine my like terms here, 1/4 y plus 1y is 5/4 y. If you needed to make a common denominator, that would be fine, but I'm going to just kind of skip doing that. And then I'm going to subtract 11/4 from both sides. To subtract 11/4 from 7, I need to have a common denominator, which would be 4. So 7 is really like 28/4. And when I subtract 11/4 from that, that would give me 17/4. And then I'll subtract the 5/4 y onto the other side to get the z by itself. And so that is my last component in my parametric solution. So again, it didn't matter which one we chose. Either one of these is fine. And had you isolated at the very first step, instead of eliminating the z's, had you eliminated x's or y's, we could have come up with a parametric solution that involved z. So there's always going to be at least 2 versions of a correct answer. Most of the time there's going to be 3 versions. It does not matter to me which one you supply. When I am grading something, I'll solve it all 3 ways and have all 3 versions. So you don't have to worry about that. Is that okay? Okay. If you look at the content library, you'll know that notice there's a chapter 3 homework 6 in there. There are some infinitely many solution problems in here. Not all of them are infinitely many solutions, but there are some in there. If they do pop up, you should give a parametric solution, just like we've done. I think I have 5 systems there to do. And we'll just work on this until it's time to go. And this will be part of the Sunday homework check. Is that okay with everybody to finish out our day here? Okay, so I'm going to stop the recording.